Listen, it's not very often when you're running a conference and all the different technologies that are in the room, and somebody actually gives you a sample of what they can do. So the president of Orfoncé, who's about to speak now, gave me a picture of myself printed 100% with bio ink. So this is all, you know, non-fossil fuel ink. Yeah. So let's have the president of Orfoncé come on up, and I've never been given a bio ink or anything from bio ink before.
Thank you. Hello, everyone. My name is Alireza, and I'm president of Orfoncé. The problem that I have with bio industry is everything is expensive. Bio food is expensive. Bio fuel is expensive. Bio clothes is expensive, and this money, changing money, we couldn't compete with the petroleum industry that produce cheap material for people, ordinary people. But here I want to present a material that it's cheaper than petroleum products, which is which is bio printing material for printing. Farima and I came to Canada in 2017 from Iran for our study, and after our graduation, 2 years after our graduation, we decided to establish our company together and to replace the petroleum-based material with the bio-based solutions. And right now we are incubated and with Sadeghi, and we're located at Quebec City. Those pictures are our products with inkjet printers, 100% organic. The market that we are targeted is packaging industry. If you produce everything, you need to put in some packages and ship to your final customer. And this is the market that we targeted, and we want to replace the labeling and packaging, the printed material on the packages with the bio solution, bio product. This is the picture that we see every day in front of our apartment door. But what is the problem with the petroleum-based printing material? All of them are expensive. If you have any printer in your offices, if you want to buy a toner or ink, it's very expensive. And they are based on the petroleum. They have high carbon footprint. Also, they lose their resolution after during the time due to UV and oxidation, and they are toxic for your body, for your children at a school who are using this printing material for 20 years if they want to go to the PhD. And his material normally comes from the combustion of heavy petroleum, and this is not safe. For the recycling also, we have a problem for the recycling. All the pulp for the recycling, they washed with water, and this water can go through the environment. In Canada, just 4% of the water pollution comes from the paper recycling. If you divided this amount with the revenue that this industry are generating, it's too much. What is our solution? We found a biopolymer from wood waste, which can be applied onto the paper, metal, plastic, clothes, and print. And we can use it for inkjet printers, for digital printing, or office printers, and flexography printing, and for labeling, packaging. And also we are started to produce biotoner for laser jet printing, for offices and digital printing. Our material is a new innovation in the market, which normally ink is produced by some powder, black powder, with a petroleum-based polymer, and some additive and solvent. The pigment or solvent could be organic, but we have petroleum, polymers, and additive. But our material is wood extraction plus biosolvent. And this makes our different from our competitor in the market. Our material is 100% organic, simplify the recycling of the paper recycling, and it's resistive to UV and oxidation. And it's affordable and without any polyaromatic hydrocarbons and heavy metal, and also it's reduced 84% of carbon footprint of printing and packaging in the printing industry. If we compare it just for office space in Canada, just for office space, not for packaging or labeling or whole packages that you received from Amazon or from Costco you buy, just for office space in Canada, we can save 3,000 tons CO2 per year just by replacing our ink with the petroleum ink. We use our ink for printing. This is our new formulation of ink. We use it for inkjet printers. You can see it's not distinguishable from the petroleum one. Although it has higher quality and higher resolution, because petroleum one has black powder and the powder has size and they cannot go through the small resolution. But our material, we don't have any particle. We can decrease the particle, the drop size, and reach to highest resolution that we can produce with the printers. And we also are collaborating with ICI, is a Printability and Graphic Communication Institute in Montreal, and we have planned to test our material into their pilot scale flexography printers to check the compatibility of our material with the printing industry and packaging industry. The good news here is the shear rate for packaging industry. Imagine, for packaging industry, they have one people or two people. They test every day the ink and find this shear rate, viscosity to shear rate, and adjust the velocity, the speed of printing by the viscosity. Our material is not dependent to the shear rate, and they can print as fast as they want, and this is our different, and we can save a lot of money for printing and packaging industry. This is our plan to bring this wonderful material into the market. We have right now, we started at home. We started with the Walmart and the Halagama equipment, less than $100. And right now we are at lab scale. We are at the 1 kilogram per day scale, and we have planned to reach to 100 kilogram per hour by 2026. And we also have other projects to produce conductive ink for printing RFID for smart food packaging. We are collaborating with INO, Institut National d'Optique, and Quantino and Pearl Technology, which are specialized in the RFID and optic. And that's it. Thank you very much.